So as I trailed at the end of the last video, we're interested maybe in exploring the data a bit more. This can be quite common. So you do some exploration, and you find that there's something that you're not quite measuring, and you want to get a better sense of it. And in this case, it's what I'm going to call advertising. And that's not, I mean, there's the term advertising and marketing are, can be used to mean exactly the same thing. In this sense, what I mean here by advertising is that the advertising is the amount spent on marketing per unit. So in order to do that, I just take the marketing spend and I divide it by the total sales for the product. So for every product that I sell, what's the marketing spend divided by what's the marketing spend for that particular product to sell? So I can do that easily with my data frame. I can just add a new column called advertising, which is just takes the marketing spend, which is £1,000, and then divide by the number of sales, and that will give me a number for how much money is spent per unit sold on marketing. So essentially, advertising is the marketing per unit. It's a bit of a nebulous measure because if the sales change in the future, this value will also change, even if the marketing stays the same. So it's not an absolute measure that unlike the price and the profit per unit, obviously they can change as well, but they tend to be more fixed. This is a bit more nebulous because as the number of sales change, this will change, whereas those things don't. Okay, let's do a bubble plot of the profit versus the advertising versus the sales. So standard code for the bubble plot. Okay, we're doing profit versus advertising versus sales. So this is a bit like the previous one, marketing versus sales versus profit, except that now I'm just adjusting the variables. So there's profit versus advertising, and then sales determines the bubble size. And now I can put in some lines, horizontal lines now representing marketing per unit. I should say that I didn't just, I'm not just thinking, oh yeah, I'll just do profit versus advertising versus sales and just come up with this. This took a little bit of work to get to this particular figure, and I decided this was maybe a good illustration of what we could do. So it takes a little work. You can't just think, I'll just pick any of the three variables and I'll just do a bubble plot. You have to think, why would I want to do this? But this helps. I hope you'll see when we look at the resulting figures that these lines are going to give us some indication of things. So what have I done for the lines? I've got these spend limit lines are now horizontal. Okay, so they plot X values going. So take the bottom one. They plot X values going from 0 to 25. But set it with Y values set to 2 all the way along, and that's £2 per unit. Because on the Y-axis we've got advertising, so that's the advertising spend per unit, £2 per unit, and then same for the next one is at 1. Advertising is 1, so that's £1 per unit, and so on. Let's see the picture. This is what the picture looks like. Let's draw that much bigger. So there it is. That's showing us that the amount of spent per unit for the really big selling products, AF and L, is much lower than 0.25 per unit. Okay, so they go at the bottom of this chart this time because advertising per unit is on the and is on the top. Advertising is on the left hand side, so advertising per unit, as it goes up, they're spending more per unit. But what can we observe from that? So what we can see for this is that anything above this break-even line, I've set this break-even line, this magenta line, to be the profit, where the profit equals advertising. So it's just drawing a straight line essentially through. So if I got 5 profit on the bottom axis, that should match up to 5 advertising per unit. So that's the break-even line, and you can see anything above that line is actually making a loss, because the cost and the profit are all being eaten up in advertising. Sorry, the profit is being eaten up in advertising. So the cost doesn't take into any account. Cost doesn't take marketing into account. So the cost per unit is how much the company pays to get it in, and then they spend some more money on marketing. In these cases, they're spending so much on marketing that these products, K and Q, are actually making a loss overall. However, U, although it has the highest advertising spend, it also has the highest profit, so it's actually comfortably making a profit per unit sold. So this is what it's telling us. Perhaps we didn't really need a bubble chart to do this. Actually, the sales aren't particularly helpful in this case. We're just really looking at profit versus advertising. But that can be quite a useful tool to do a bit more analysis. Now, what else can we do with these charts? This is a technique I wouldn't necessarily recommend it, but what we can do is use log scales. I just thought I'd mention this at the end of this lecture, because if you find that you get a chart like this where everything's clustered at the bottom, what you can do is introduce a log scale. So a log scale is not it's not linear, it's logarithmic, which means that all this stuff at the bottom is going to get stretched out, pushed further apart. So the code's almost exactly the same, except that now I just have to tell Matplotlib I want a log scale. So you can do this with almost any chart that we've looked at so far. It's just you have to be slightly careful about the interpretation, because it's not so easy to interpret these kind of charts. We have to adjust the profit advertising break even because this now has to become a curved line in this log space. So this is what it looks like when I do that. So this is a kind of advanced technique. I wouldn't necessarily recommend doing this, but it can help to elucidate some of the data here where it's all too clustered together. You can't even see the AF and L. They've fallen off the bottom of the chart here. But you can see there, this is helping us to see that, to understand that chart, but actually spreading this data out a bit more, so we can see, where the amount spent per unit is going. Look on the left-hand side, the log scale is telling us, these aren't linearly spaced out. They're spaced out logarithmically, which means that the ones down here would be much closer together. Okay. Yeah, so as I said, the high volume products have dropped off the bat. It's because they actually have negative log values in this case. So that can be a useful technique, but it makes it harder to interpret the chart that you're looking at. So use it with caution, putting in a log scale. So let's think about what we've seen, just to summarize the lecture then. What have we seen from the data? We're not making business decisions, but we can see that we can compare more than two variables in a variety of ways, and we can see that some products are making a loss when marketing is taken into account, and some products, e.g. L and U, could have higher marketing spend. So U, you might, there's actually the number of conclusions that you could draw about U. It's got very high marketing spend, but it's got a very high profit. You could spend even more on it, or you could take the profit down, or both of those things. So we're not making those kind of business decisions, but we can identify in the data that it's a bit of an anomaly in terms of our data. We can definitely see from this radar plot, however, that there's no marketing spend on L, and that could maybe because that's actually a very profitable item that could be used to drive up the sales, to push it up higher. Okay, what about the lecture summary? What we've seen then in this lecture is we can see how to, or we can get a sense of how to visualize data sets with higher dimensions. And dimensionality is often quite a big problem in visualization. So it's when we've got a lot of comparable dimensions like the time series, then it's quite easy to deal with. But when we're dealing with a lot of variables that have got completely different scales, completely different types of values, then the number of those things, or the dimension of that problem, makes real difficulties for visualization and data exploration. We will come onto this a bit more towards the end of the course when we look at dimensionality reduction and we look at clustering. But for now, that's just to give you a sense of what the dimension means. We've seen how to visualize data sets with higher dimensions. We can use comparative bar charts and radar plots. We can get, as you saw, we could get 5 dimensions in comfortably. We'd probably get more than that, maybe 10. Correlograms are another useful way of visualizing the correlations in a heat map. And we can also use these bubble plots, but they can only do 3 dimensions at a time. These are all sort of essentially separate techniques, and some of them, are more useful than others. It's not always obvious which to use, and you sometimes need to apply some reasoning, and it can be more of an art than a science. So picking, for example, in those bubble plots, the variables that you want to visualize can take a bit of thinking, and there's no right answer, so you may end up with not necessarily picking the right ones. That's more a case of experience and just trying these techniques out. Okay, I hope you found that interesting. I'm going to finish there and see you next week.